Let's solve this problem. LeetCode912 sort an array. Okay, so given an array of integer names, sort the array in ascending number. Here is the example. Okay, here is a duplicate or not. So, we actually solved this problem in previous video. We used a quick sort, the two-way partition, and a quick sort for three-way partition, and also we can use merge sort for this problem. Okay, so for this problem, if you are interested in watching the merge sort or quick sort, you can actually check out my channel. I have some videos is talking about merge sort and quick sort. So in this video, I'm going to use heap sort to solve this problem. Okay. So first, what are we going to do? So let's talk about heap sort. Okay, the heap sort. So this algorithm, we have different steps for this problem. The heap, sorry, should be okay. Heap sort. Okay. So for this one, we have different steps. So first, the step one. So the first we are going to build a max heap from the input data. Okay, and then we're gonna replace the root node with the last node of the heap. Okay, this is the procedure. And then what we do, and then we delete, and then we deleted the last node from the heap. And then finally, we do happify the root. Okay. So, and then we repeat. Step 2. And then we repeat step 2 until here only have one element left. Until only one element left in the heap. Okay, this is basically the procedure of heap sort algorithm. Okay, so we have to notice we have property of max heap. How to check if it's a max heap? Okay, max heap. Okay, so in the max heap, the parents. Okay, the parent node is always greater than or equal to child node. Okay, it's basically the property of the max heap. Okay, so how to calculate our left nodes? That's another one. The left child node. Okay, so if we have parents, the left child node index. Okay, how to do it? So if we have parents, so it's gonna be 2 times parent index plus 1. Okay, the right child node index. This one equals to 2 times parent index plus 2. Okay, this is basically. And how do we get the parent? this parent node index. So what we do, we actually floor, okay, we floor the index minus 1 and then by 2. Okay, this is the formula. Okay. Now we are going to have a question. No, we are going to use this example. Yeah, we are going to use this example. Let's, okay, this is an example of this one. So first we are going to build, we build the max heap. Okay, how do we do that? So we build the maximum. So first we just do, this is a 5, and here is 2, here is the 3, and then here is 1. Okay, this is the input data. Input the input data we transfer to to a heap. Okay, and then we heapify, make it the max heap. Okay, how do we make it as first we build this heap first from input data, and then we change it to a max heap. So how do we do that? So how do we do that? So we check each node from bottom to up. Okay, and then we use using heap property. Property is like what? Like the parents always greater than the child, right? To heapify. Okay, so how do we do this? Okay, from this one, let's check. Okay, so for this one, let's check. Start from here. Here we don't have a left child or right child. So and then we do this one. So 3 we don't have left or right child. So this one we have left child. So we check if 2 is greater 1, yes, greater, and then we check this one. Is this one greater than the left child and right child? Yes. So that means that this heap is already a max heap. So because this example actually yes, but for some another example, if it's not, then we have to swap. Okay, if the parents is not greater than the child, we have to swap. Okay. That means there's a heapify. Okay, in this case is already a max heap. So, and then we start a remove, and then we start remove the nodes. Okay, we remove the body nodes. Okay, so how do we do that? So we just do so in this problem, let's copy this to here. So for this one, first we're gonna swap the 5 and 1, and then we remove that one. So what do? We do this way. So we swap this 5, here is 1, and then we remove the 5. How do we? Yeah, let's do this way. It's removed. Okay, and then we only have this one. So let's check this one. So we check this one because it's a leaf node, and then we don't have left and right child, and then we check this one, no left and right child, and then we check this one, we have left child and right child. So and then we need to swap with the left child, which one is greater, this one greater. So we swap this one. Okay, so how do we do that? Sorry about that. So here gonna be 3, here gonna be 1. Okay, so we remove the 5 and then we heapify. Okay, we heapify. So and then we do again, and then we do this one, Okay, we swap 3 and 1 first, okay? And then we swap, here is the root with the last element, okay? And then we delete the last element, okay? And then we happify this one. So this one is left, we don't have to check. And then this one is greater than this one, no, then we swap these two, okay? So it's gonna be 2, and here is gonna be 1, okay? And then what we do, and then we do this too. And then we do this too. We swap this one, the root, with the last element. And then we delete the last element. We check this one yeah, this one is already heapified because only one left man. Then so only one element left in this heap. So algorithm end. Okay, it's basically the algorithm of the heap sort. Okay, so let's talk about the time complexity for this problem. The complexity, okay, the complexity is gonna be ON. So why the time complexity is ON? Why this one is ON? Okay, because let's give this example, the input data. We still use this example, okay? The input data here is like this. And then after we build the tray, it's gonna be, looks like this. After we build the tray. Okay, let's say it's gonna be, looks like this, okay? And here is the 0. That's the index, okay? This is 1. This is 2. This is 3. Okay, yeah. So for this one, we can see here is the height in the left one is 0, and the height here is 1, and the height here is 2. Okay, so let's calculate the max node. The max node in each level. Okay, the height is gonna be the ceiling of n by 2 to the power of h plus 1. Okay, this is a formula for that. Okay, h is the height of the tree, n is the total length. Okay, so after we calculate, so in this level, okay, in this level, the max number of nodes is going to, like what? Is going to how many elements? 1, 2, 3, 4. So we total have 4 elements, right? So we have 4 elements by, and then this is 0. 0 plus 1 is 1. So it's by 2, okay? 4 by 2. Okay, let's do this way, right? 4 by 2. 4 by 2 is equals to 2, right? Equals to 2. So the maximum is 2. And then similarly, we can calculate this one. So the this one, so we total have 1, 2, 3, 4. We have 4, right? Length we have 4, and then this one is 1. So is 1 plus 1 is 2. 2 to the power of 2 is 4. So here is 4. So that means that we. Okay, just 1 second. Let me calculate again. Okay, for this one, let's continue this. Okay, let's continue here. So for this one, the max number for this level, let's do this, and then is 4. 4 by actually here is 8. 8, and then is gonna be 1. Okay, so basically, this is a formula, and then let's check out the term complexity. Okay, so the term complexity actually. The sigma, actually sigma from 0 to log n. Okay, so and then this is our equation is n by so basically this is the max number of nodes. Okay, max number of nodes in the level h. Okay, this one, how should we do? We just do like a max number of node. Okay, this one, and then we plus O H. Okay, yeah, because we have a H level, and each level we actually have the time complexity of the maximum of number of nodes in each level, and then we total have a H level. So this is a time complexity for the level 0. So it's gonna be this much, and level 1, level 2. So that's the sigma start from 0 to log n. We total have log n. So for this problem, it's gonna be what? Okay, let's do this. It's going to be like this. Let's do this. So it's going to be this, and we times h. Okay, and then when we try to check here, see we have 2 to the power plus n. So here actually is equals to this mathematical problem. Let's solve this problem. So this one actually equals to h times 2. Okay, and this one is a constant. This one also constant, and then we are trying to round it something like this. So it's gonna be like this one is n, right? This one is 2, right? So it's gonna be n by 2 and n by 2, and what do we do? N by 2, and we're gonna do this one. Here gonna be h by 2 to the power of h. Okay, this is the kind of, and the sigma from 0 to n. Okay, the h sigma is like we need to, okay, it's like this, okay? So let's do this problem. So it's gonna be n by 2 and also times this part. So this part is going to be 0 by 1, right? When h equals to 0 and h equals to 1 is gonna be by 2, and when h equals to 2 is gonna be 2 by 4, right? This one equals to 0, 1, 2, right? So it's going to 2 is 4, and then 1 equals to 3 is going to be 8, and the plus 1 equals to 4 is going to be 16, and the plus, and also almost kind of 0, okay? I mean, like if the log n is infinity, okay, here is log n. So this part, let's see this part. This part is equals to 1, and also, you know, this part also equals to 1. So 1 plus 1. So this whole part actually almost equals to 2. So it's gonna be n by 2 and then times 2. So, and then it's n. So that's why the term complexity is n, okay? In this video, we just talked about the algorithm of max heap, how to do the heap sort. Okay, okay, in next video, I'm going to actually writing the code because I don't want the video is too long. This only for algorithm explanation, but I'm gonna to make another video is for the heap sort, the coding. Okay, the coding part. Okay, thank you for watching. I will see you next time.